Good morning, this is your captain speaking. Please keep all phones put away and on silent if you know eating in class, and if you have any questions or concerns, please ask your attendant. Thank you for flying Integrated Math Airlines, and happy mathing.
Hey guys, let's go over the Module 4 test version A, which is the following. So you're going to use all of this for questions 1 to 3. Suppose a function is g in nature defined for all real numbers of x. So g is x minus 6, and h is 2x squared. Well, don't forget you have to have this minus sign. So this is like a -1, and you can distribute, so negative x, and that's a plus 6. And then that would be choice B. Okay, which represents g times h? So g is, remember that's times, or multiplication, so x minus 6. And then blue, this one is times 2x squared. Okay, so you could do a monomial. You can just rewrite it if you wanted to. You could do like this, and then you can distribute, or you can do a box. So I'm going to get 2x to the third minus 12x squared, and that'll be choice C. Okay, question number 3 is a composition function problem, so you can rewrite it like this. And really what they want you to put in g of -3 first. So let's do that. So this is going to be g of -3, and then I have x minus 6. So -3 minus 6 is at -9. G of -3 equals -9. So now I'm going to take that -9 and put it into h. H is 2x squared. So that gives me 81, so that gives me 162. C is my answer. Question number 4, match the order pairs of the composite function to which they belong, so circle either A or B. So they give me, my first input is -2. Let's start down here at G, so I'm at -2. Then I go to 1. That's my output, so now I go to 1 on the other side. I get -4. Okay, so that didn't work. So let's go ahead and try the other way. Start -2, 8. A is my output. Now I'm going to go to G as my input, and I get -3. And that matches. So we started here at F, and then we end at G. Remember, you start on the right to left. Okay, question number 5. Which of the following is equivalent? So you can break down 81, that's 9 and 9. And that gives you 3, 3, and 3. So you really have 3 to the 4th power. Y to the 12th power. And then remember our phrase, for the fraction, you have the top and you have the bottom. And then for the radical, you have bottom out, top in. So that 4 is now on the outside of the radical, is going to become the bottom of my fraction. So it'll become 3 to the 1st and then y to the 3rd. Okay, so now I have to go through EVO. Is this an even? Yes. Is there a variable? Yes, it's a variable. And you have an odd out that is true. So that basically means you're going to put that in absolute values, and that would be choice C. Okay, question number 6. Let's break it up into 7 and 7. You have an index that's invisible, it's 2. So really you have this. So 7 squared, z to the 8th, out bottom. And just simplify. So 7 to the 1st, z to the 4th. You can apply EVO. And you realize that this is an even. This is a variable, but this one is not an odd. So it's just 7z to the 4th, which would be choice, whoops, A. Okay, number 7, which graph does not pass the vertical line test? So remember, for a vertical line test, you're basically going through each of these. So not pass would mean, I liked it, someone had it on their paper, they have 2 dots. Because pass would only be 1 dot. So this one does not pass. Those are only 1 dots. You can put them anywhere you want, so 1 dot, and those would be 1. So my answer would be A. Okay, back sign. Which one is not equivalent to x to the 1/2? So I'm just gonna work my problems out here. Okay, for A, I have x to the 1/4. So when you're multiplying with the same base, you get to now add the exponents. Remember, when you're adding, you add across and then you keep the denominator. So that'd be x to the 2/4 divided by 2. You're gonna get x to the 1/2. Okay, C, x to the 2. Okay, this one you have a power to a power, so then you're multiplying. Make that a fraction. For fractions, you can multiply across. So this gives me x to the 2/4, and then same thing as above, that'll give us x to the 1/2. So let's write that. X 1/2, x 1/2. Okay, let's do D. Let's do a different color, D. Square root of x over 2. Okay, this one has some invisible numbers. That's a 2, that's a 1. So you get x to the 1/2 over 2. And then you don't do anything. You'll notice that we're looking for 1/2s, but this one has a denominator. Okay, so let's write that. X to the 1/2. That's really bad. X to the 1/2 over 2. And then the last one, E, x to the 3/2 over x. I'm going to move this one up, so it'll become x to the -1. And to make that -1, put it over 1, and then I'm going to multiply by 2, so as a common. So x to the 3/2 minus 2 over 2. So that'll give us x to the 1/2. Okay, now it says which one is not. Okay, so this is 1/2, 1/2, that one's 1/2. The only one's not x to the 1/2 would be choice D. Okay, number 9, given the following functions, are they inverses? So to test if they're inverses, you're going to do 2 problems. Whoops. F, and then put in G into F. And then the other one is the other way. And if they're equal to x, then they are inverses. Let's do the G into F. So if I write F out, And then I'm putting g now into f. So that's like g of x, right? G of x. So instead of writing g of x, now we write 2x plus 3. 2x plus 3. Okay, so I don't need the parentheses, so you'll just get 2x plus 3 minus 3, and those equal 0. So now you have 2x over 2, and if you reduce, then you have x. Okay, let's do the same thing on the other side now. Let's put in g. And again, we're putting f into g, going right to left. So this is f of x. Instead of writing f of x in there, I'm going to write x minus 3 over 2. Don't worry about the left side, worry about the right. Okay, you put it over 1. You can cross cancel there. If you distributed the 2, you'll eventually get the same thing if you divide by 2. So you'll get x minus 3 plus 3, and then these cancels, you're left with x. So they're both equal to x. The answer is yes, they are inverses. Okay, number 10. Perform the indicated operation. I do want to point out that that is an open circle, which means it's not multiplication. It's composite functions. Okay, composite function basically means g of h of t. That's what it means. So you're putting an h into g. So my trick is write g first. I wrote capital T's. Okay, now we're putting an H in there. Let's do pink. So instead of T's, now I'm going to write H of T. And then instead of writing H, we're going to be writing over here negative T squared minus 3. Negative T squared minus 3. Put that in parentheses. Okay, so all you have to do is distribute. So I'll get negative 4t squared minus 12. And then I can drop the parentheses now that I distributed at plus 1. So my final answer is just going to be negative 4t squared minus 11. Okay, number 11. Simplify your answers should only contain positive exponents with no fractional exponents in the denominator. Answers with no work will result in a 0. First thing I see is a negative. You can bring that one down. So I'm going to have in the denominator x to the 1/3 and x to the 2/3. Okay. Here, you can just divide. 81 divided by 3 gives you 27 in the numerator. Okay, so I have 27 now. And then you have the same base. You're multiplying, so you can add the exponents. Go ahead and just add across here. 1 plus 2 is 3. That just gives you 27 over x is our answer. Hope that was helpful. See ya. All right, I wanted to show you guys how to do this problem in a different way. So you can just use your skills of negative exponents. So if you turn 81 into 3 to the 4th power, x to the negative 2/3, this one can move up by negative. And then this 3 can come up too by becoming 3 to the negative 1 power. So everything is in the numerator. So then, you know, you're multiplying with the same base. So you add the exponents, -1 plus 4. Then this one will be x to the -2/3 minus 1/3. And then if you finish that up, that'll become 3 to the 3rd power x to the -3/3. So that'll become 27 x to the -1. And then that -1 would come down, so you would get 27 over x would be our answer. Okay, if you work with division of exponents, I didn't get to show you guys this by the time of the recording of this. Of this video. So division of exponents says if you have x to the a over x to the b, then really what you have there is a subtraction problem. That big division sign actually becomes a minus sign. So that is another way of doing that problem. So let's go ahead and try to do that. So again, if you turn 81 into 3 to the 4th power, you have 3 to the 1st power, that's x to the -2/3, x to the 1/3, and if you just apply what we just said, same base, you have multiplication there, so it'd be 3 to the 4. Let's use that green again. So that big division sign becomes a minus sign. Do it over here too. So 4 minus 1, and then x to the -2/3 minus 1/3. This one should not have been there. And then if you simplify that, you'll pretty much get the same thing. 3 to the 3rd power x to the -3/3, and then you would just simplify like we did. That becomes 27 over x.
Math is the best. Math is the best. Math is life. Mr. Eng, the best teacher in the West. We're so blessed to have Mr. Eng. Praise Jesus.